Okay, I see we've got a bunch of people that have joined us today, so thank you very much for coming along. Quick introductions. I am Mike Sheward. I'm the head of security at Particle. You may remember me from such webinars as the security one a few weeks ago and various vendor webinars that I've done over the years, usually in exchange for sports events tickets. Given that 2020 has been a year without many live sporting events, I haven't done any of those for a while, but in 2021, Seattle is getting a hockey team. So just throwing that out there, security product vendors. I'm super excited to introduce and have joining me today Debbie Gillespie, who is one of Particle's finest SRE professionals. She's been with the company about 3 years, and she has taken the time away from the nuts and bolts of the platform to come talk about some of the work that we've been doing this year on reliability. So Debbie, why don't you give us an introduction to yourself?
Thanks, Mike. Excited to be here. My name's Debbie Gillespie. Uh, Again, senior site reliability engineer. Most of my background is in software engineering, spent a number of years as an app developer, eventually got interested in infrastructure as code and the DevOps movement, and that's how I found myself going into the site reliability engineering. Been working with Particle for 3 years now. It's been a fun ride watching the many ways that we have improved our platform to make it more reliable, more scalable, and meet the demands of our customers. Back to you, Mike.
Awesome. Yeah. So we're gonna do we're gonna break the presentation today into three phases. The first, we're going to talk about kind of our journey so far, and it's the journey which, as Debbie just mentioned, she's been on for 3 years, so she's been pretty key in delivering a lot of this stuff and getting us to where we are today. And then we're going to talk about the next phase, and we're going to talk about the steps that we're going to take to improve reliability and some of the work we've got queued up as we move into 2021 that will help all users of our platform. And then finally, we're going to talk a bit about a topic that's obviously very near and dear to my heart, which is the crossover between reliability and security. Two topics with very similar aligning goals. And so we at Particle kind of address them in very similar fashion. So we'll talk a bit about that as well. But to get started, we'll talk about this year and how we keep your physical world online. And that's obviously the mission of Particle, is to connect the physical world. And earlier this year, we hit a pretty big milestone, 100,000 daily online devices. And the reason that I think we were able to get there is early in the year, we all got together in person while we could still do that. And we made a decision as an engineering organization and as a company to concentrate more on reliability and quality over, say, feature work. Feature work is obviously very fancy and something that we all like to do, and kind of reliability and SRE type work is something that doesn't often make the headlines, if you like, as much as feature work, which is fine, because that's how it should be. We don't want to be in the headlines. So Debbie, talk to us about some of the major work that we've done in 2020 to get to the point where we can easily support 100,000 daily on the online devices all around the world.
Well, in 2020, one of the biggest changes we did in 2020, I would say, would be the work we've done on uh, load testing our infrastructure. It's easy to load test, say, an API or a web service. You can throw Apache benchmark at it and simulate a load. It's much harder to simulate that when you're dealing with devices that are connecting to our cloud. And so one of the great new features we did was we spun up a way to simulate Particle devices hitting our infrastructure, so we could simulate the load of 100,000 devices and figure out how well we handle that increase of load.
Yeah, that's been a huge area of improvement for us. And like you said, Particle is, for a lot of folks, critical infrastructure for their business. So we are, hyper aware of that. It's not quite the same as just running a website or an API, like you said. There are a lot of moving parts to keeping all these devices online all around the world, and simulating that accurately has always been a challenge. And I think we've made great strides there. Let's talk about some of the tools that we use to make sure that we keep everything online for everybody. Starting with probably the most important building block of it all, Terraform. So Terraform, as I understand it, is the infrastructure as code tool that we use. It gives us really nice auditing capability, which is obviously something I'm super excited about, being in security. Can you talk to us a bit about how we use Terraform to kind of build the core blocks that make the particle device cloud what it is today?
Absolutely. So, we rely on AWS for much of our cloud computing. And the great thing about those kind of services is they provide a really nice interface for spinning up new infra, making changes. One of the things they don't do a great job of is helping to provide a way to track what has changed or who changed it or why they changed that. And that's where Terraform comes in to help us manage our infrastructure in a very scalable way. All changes that are happening to our infra are going through Terraform. So we're committing code to a GitHub repository. There's a pull request. Somebody reviews that pull request. We then, can apply those changes and see how they look, apply it to staging, and then eventually move that on to production. And so it's a far more scalable way to manage the infra. And again, most importantly, having that audit trail of knowing who changed things, when did it change, and you can also track why it changed in your GitHub commit messages, which is, these are things that are just not available to you in the interface that AWS provides.
Yeah, and I remember actually probably almost 10 years ago working at a large software as a service company, and somebody made a change that wasn't properly documented on physical hardware in a data center. It was a load balancer. And then they disappeared on vacation for 3 days. Unfortunately, that change broke something, and without the proper documentation and audit trail to figure out what had actually happened and what changes had been made there, it was very difficult for the rest of us left behind to figure out why we were seeing the behavior that we were seeing. And we spent like 3 days locked in a war room trying to figure that out. So yeah, I am a huge fan of Terraform, although I'm not a huge fan of YAML, which is what all the Terraform configurations are written in. I guess it's kind of a defensive thing that if somebody, malicious tries to write YAML, they might not get it first try anyway, because it's very difficult to format it correctly. One thing I forgot to mention, by the way, is if you have questions that come up during this session, feel free just to throw them in the Q&A and we'll address them at the end. I forgot to mention that at the start. So with Terraform, we have the core building blocks, and then the next thing that kind of is the next layer up in the infrastructure is Kubernetes. And Kubernetes is a container orchestration platform that, to me, is kind of a dark box of wizardry and magic. And that's the way it's going to stay. Debbie, can you talk to us a bit about how we use Kubernetes to make sure that the platform stays online as well?
Sure can. And I will agree, it is dark magic and wizardry. That's part of why I like Kubernetes, because it handles all the voodoo magic behind the scenes for you and makes what used to be a really manual process not so manual, and just it's magic. When I started at Particle, we were not using Kubernetes. We were managing our infrastructure with Chef. And then, we did we were containerized for many of our services, but we were using Docker Cloud to manage that. And Docker Cloud was not it was a great tool at the time for what was available, but it was, lacking features. And eventually Docker actually closed it down and said, we're not supporting this anymore. It's not making us money. Nobody really likes it. And so then we had to move to something else. And of course, at that point, Kubernetes was available. We moved to our own self-hosted Kubernetes, though, because AWS didn't have a Kubernetes offering. Their only offering was ECS, the Elastic Containerized Solution, which was also not a great fit for what we were looking for. So then eventually AWS supported a hosted solution, so we moved to that. Winding back, though, I mean, to dispel some of the myth of, what's the black art and wizardry behind it. Essentially what Kubernetes is it's an orchestrator that allows you to manage deploying your containers out in the cloud. And so it had, what used to be a manual process, it can handle with ease. So it can take, I've got a set of pods that I want to get deployed out into production. And I can tell Kubernetes, like, I think it's going to need this much CPU, it's going to need this much memory. And Kubernetes can take a look at the available, and Kubernetes knows what nodes are available to deploy these different applications to. And it can quickly assess, do I have enough memory? Do I have enough CPU? Where should I schedule these pods to be run optimal? Where's the most optimal place for us to schedule those pods? And so, Kubernetes was a big game changer for Particle because it manages all of this for us instead of it being a really labor-intensive process. And it simplifies things like scaling. If you want to add an additional pod to your node, you just you just change the configuration and say, actually, I want to run 25 of those, not 20 of them. Can you do that? And Kubernetes will assess if there's enough space. If there's not enough space, it won't push it out there. It'll keep your existing stuff running. And, so it allows for zero downtime deployments. In which it will spin up, you've got your existing pod with your, version X. And then if you want version Y pushed out there, it'll spin that version Y up, check to make sure it's healthy. And then it'll also handle the routing of traffic from that, version X pod to version Y. And so, it really enables it to be easy for our developers to just push their changes out to production, and they know it's going to work just fine and they're not going to take the service down in the process.
That's incredible. And to think, a few years ago to buy a product like that could do that, it would be, an enterprise product that would be very expensive. And Kubernetes is open source with a huge community behind it that supports it. So we thank them for all their hard work. It allows places like Particle and other startups to be able to deliver that kind of enterprise grade reliability. So thank you for all your efforts, Kubernetes folks. One of the things that you just touched on there was the idea of doing split deployments. At Particle, we use the terms blue-green deployments. I apologize to the marketing team for my use of a unapproved green particle here, but just to prove the point. And it allows us, particularly when we think about the device service, which is kind of the main core service that all of our connected devices talk back to. That's something that we have to be extra careful with, because as we said earlier, it's critical infrastructure for a lot of our customers. Blue-green deployments allow us to kind of gradually make changes. Would you describe it as that, kind of slowly rolling out changes in the daytime and making sure that the deployment process is kind of more smoothly managed?
Yeah, it's definitely, it gives you more control over that deployment process. We don't use blue-green deployment for most things. We just let Kubernetes do its magic and it's good. But for the device service, it's a little more of a complicated piece of infrastructure. And so, it allows us to spin up a new version of the device service and then manually route traffic to that in a controlled fashion and watch how things are working with, obviously we test things in staging and vet things there, but there's, there's a belief in some engineers believe you should, I only test in prod. We test in staging, but we also test in prod because there's sometimes no substitute for the traffic that your customers provide. It's hard, we've got, I was talking earlier about the load testing info we put in place, which is great for simulating load. It still doesn't fully approximate what a customer is doing because that's unpredictable to us. And so that's part of why we really like the blue-green strategy, to give us that controlled rollout of a new feature and the ability to roll back quickly. And again, because we're dealing with devices, we really need kind of that staggered approach to route to, stand up the new thing, and then we're just using DNS to route it to the new service.
Absolutely, yeah. It's like you say, it's a challenging piece of infrastructure, but I think we do a lot of good work there to make sure that we mitigate as many risks as possible. Technology is, of course, a huge part of what we do. But the other kind of side of the coin is the people that we work with. And obviously we have folks all around the world. Those markers on that map there are the actual locations where particle folks are based. We have historically been a remote engineering team, and obviously now this company, along with many others, has pivoted to being a fully remote company, but it wasn't significant as much of a significant pivot as some places, as we already had a great percentage of folks working remotely anyway. So I think because of that, we kind of set up with that remote first kind of mindset, and having tooling accessible from wherever we are, and the ability to kind of respond to things as they pop up from wherever we are. And the other thing that's super powerful at Particle is the on-call rotation that we have. And in some places, the on-call rotation, the on-call guide, if you like, the long and the short of it is, oh, you will partake in an on-call rotation as an engineer. But one of the things that we have is a really detailed run book about, what expectations are if you're on call, what things really do need a quick response, what things, don't need a quick response. And I think that's something that I think is tremendously important, because an on-call rotation that folks are on, it definitely is a life disrupting responsibility, and something that we have to make sure that people are given all the tools they can be to be successful at as well.
Yeah, absolutely. Running a solid on-call rotation is very important to keeping the platform up and running. There's, always going to be things that happen, some things that are out of your control, and you need to be able to have a team of engineers who are able to respond quickly to get things back up and running again. So it's, the detailed, setting expectations and documenting what those expectations are really crucial to making sure that people respond appropriately when things are not working. The other part of it is, the detailed run book aspect of it is making sure that, you're at times waking people up at 2-3 o'clock in the morning. It's not always when I operate at my best, and it's not when most engineers operate at their best. And so making sure we have clear instructions, because usually you get paged because some alert fires. And so we're detecting something, but we want to make sure that someone's 2 o'clock, 3 o'clock in the morning brain can quickly respond to whatever it is that the alerts are seeing, and assess, is it real? Is it not? Determine if we should pull more people in or not. And the other aspect of running a solid on-call rotation, I think, is around using blameless postmortems. You need a postmortem because we need to learn from every incident. It's our opportunity to figure out what could we do better, where do we need better alerts, where do we need better observability, those sorts of things. The blameless aspect of it is important, because if you don't have a blameless postmortem, people are going to spend more time trying to cover their own keister and cover up what they might have done. And then you never actually get to you're not discussing real facts anymore, and you can't get to real solutions. So, putting time and effort into running a solid on-call rotation is a key part to how we've kept things, keep things up and running. So people can, our customers can depend on the platform to be there.
Absolutely. The other point on that slide that I would just mention as well is that we do have dedicated teams within the engineering organization, but there's a lot of crossover, and I think our structure is really nice, in that we empower each kind of sub team within engineering to take responsibility for their applications and services, like in a proper DevOps model. But ISRE is separate in that, the focus is the infrastructure and providing the services needed to deliver other people's applications and things. But we're not say the ISRE team is not referred to as like a DevOps team. It's purely to run the infrastructure in a DevOps fashion, and all the teams are DevOps, which I think is something that is hard to get right, but I think we have a really good balance there. And kind of along those lines, when we think about how we run sprints, so we do 2-week sprints at Particle. We have a daily expanded stand-up. Note the word expanded there, because I'm sure agile software development purists will be perturbed by the 45-minute stand up because it should only be about 15 minutes. But in fairness, the first 15 minutes is kind of the stand up, and then the rest of the session is kind of designed because we're a remote first organization. So we do things like go through the stand up, go through alert triage. So this is kind of like a meta secondary triage. Alerts get triaged in real time, but we actually triage the triage, if you like. So we look at the alert and say, hey, did this alert trigger at the right time? Did it? Is there any way we can improve it? Did we miss something? That kind of thing. We always look together at the events and things collected in the security incident and event management tool, because sharing security knowledge and insights is one of the best ways of mitigating security problems and risks, by having as many eyes on things as possible. And then finally, we do kind of tidy up things like story grooming and a list of other items that we hadn't got to in the meeting that we referred to as parking lot, and then wrap up the sprint at the end of every 2 weeks with a retrospective. And I think, Debbie, kind of these meetings are really critical for a remote organization to get right. And you do an awesome job in the ISRE sprint of keeping everything moving along and making sure we hit on all these points. And I think that's something that, I think you'd agree that it's important to do that every day so everybody knows what everybody's doing, right?
Absolutely. I mean, collaboration is the name of the game. If you want good quality, you're going to have collaboration between all the people that are working together. The meetings help keep everyone unblocked, and the alert triage aspect of it helps make sure we're continually asking those questions, because alert tuning is kind of a voodoo art form in and of itself. You can't just create an alert and hope that it's good. You have to constantly ask the question of, was that signal, was that noise? Because if you let your alerts go uncared for, they turn into noise, and then people ignore them. And then when when there's actually a problem, everyone ignored it because they figured it was noise. So, having these discipline, again, I'm a big fan of process over rock stars and heroes. Rock stars and heroes don't scale very well. Process does. Process will handle the fact that somebody, we do this in a daily meeting, because then if somebody's out, we still know that these things are being dealt with and looked at, because the meeting structure itself will support that.
Absolutely. And kind of one of the more interesting aspects I find anyway of working at Particle is the fact that we make hardware products, and historically I mainly spent my career at software companies, so the exposure to hardware and manufacturing and all the other stuff that comes with that has been super interesting. I'm really excited, and one of the things I was almost a little surprised by when I started was just how kind of tight the ISRE team is with the manufacturing teams. And actually that makes a lot of sense, because it's kind of like as our products go out into the world and connect to the device cloud, it's kind of like having the people that built and designed the car come along for every drive with you, and it makes a lot of sense for detecting issues and responding to them. You work a lot with the manufacturing team. I know you meet every week. Can you talk a bit about kind of some of the things that that kind of alignment helps deliver for Particle customers?
Absolutely. So, the first experience a customer has with our device is when they're going to unbox that device and connect it to the cloud. And of course, we don't just let any device connect to our cloud. We only let devices that we know about connect to our cloud. And so we need to capture all of the devices we manufacture, and get that into our database, so that when people go to connect to our cloud, we know it's one of our devices. So we have to have a reliable way to capture information from our factories when we manufacture these and get that into the cloud. The site reliability team got involved in that because initially we were struggling with losing data. And so then customers would get their device, they'd go to connect. We didn't have a record of that device because somehow or another we managed to lose that record and they weren't able to connect. And so it's really important to us to make sure that customer, that every device we manufacture, we know about, we have an accurate representation of that device in our database, so customers have a seamless experience with unboxing their device. It is definitely an interesting the fact that we work so closely with manufacturing. I mean, our team in China, they're Particle employees. And so it's not just my team that's working with the team there, but also the developers of our embedded software are working with the team that designs the hardware. And so we've got, that close collaboration again to improve the quality.
Yeah, absolutely. Some very smart folks that do incredible work. So that's kind of how we got to where we are today. And so the next phase of the webinar will be about kind of some of the things that we know we want to work on in the next year, which I'm sure is a year that we're all extremely excited to get started on and move on from this year. The first kind of thing that we brainstormed out as being an area for improvement is the ability to auto scale. Right now, although we have a lot of stuff in place to make it as easy as possible, it's still kind of a manual process for us to go in and scale up various services. So I think kind of taking advantage of some of the native auto scaling features of our cloud provider will be the next logical step there.
Absolutely. Why make humans do the things that the computers can do? And, it ties back to, why we went from our own hosted Kubernetes to pay Amazon to do it. I want to free up our engineering time so we're not busy trying to figure out, do I need to scale up? Do I not need to scale up? Let the computer do that. And it also just gives the customers a more seamless experience because it is not relying on a human to do a thing if the computer can tell we need to add more resources to handle the current traffic.
Yep. And similar as well, self-healing and improving liveness probes and things like that. So we talked a bit about Kubernetes at the start of the webinar and how it kind of has a lot of these features built in. It's good at the infrastructure layer. I think the next kind of iteration there will be to kind of make the infrastructure a little bit more application aware, so that it can respond and react to things that are happening at the application layer that it might not necessarily do today, to kind of help itself stay afloat.
Yeah, we want to focus on fine tuning those checks of, is it healthy, is it not? Because again, we don't want to have to, if things are unhealthy, we don't want to have to wait for a human to do something about that. When Kubernetes is noticed that it's unhealthy, it gets us to that again, helps us reduce that mean time to recovery if there are issues. And the funny thing is, and I've been engineering for a long time, and one thing that hasn't changed is often the simplest solution to fix a problem is you just reboot. And so a lot of times we just need to restart the pod, and our current Kubernetes infrastructure is configured to do that. There's just more attention that we could be paying to give it some more fine-tuned health checks, so it will be reacting more quickly to when things are unhealthy, and get that restart to happen so we're seamlessly up and running and nobody notices the issue.
That's the goal. Yeah, no news is good news. Observability, we've spent a lot of time on observability tools and things like logging and application performance monitoring and error reporting this year. And we'll continue on that theme next year to make sure that we have all the insights that we need to basically offload that task from our customers and make sure that we're doing all that we can to stay on top of the infrastructure and the environment, and keep everybody connected. What do you think kind of going forward will be the next wave of observability things that we concentrate on?
Well, I think, again, with the observability, it's an art form. You have to constantly tend to it, and it's about process and asking the right questions. So, one of the efforts we've done has been improving our logging and making those more useful, adopting more structured logging. Asking the question of, gosh, it took us a while to figure out that issue. What could we have had in place to have detected that problem? Finding ways to get more data and information so when we're debugging things, we can quickly identify the source of the problem and get it fixed. Again, more focus on reducing mean time to recovery by making it easy for people to identify where there are problems.
Yep, absolutely. This one is a topic that's near and dear to my heart, as it's kind of a security one. As you know, as a platform or service becomes more popular, um, we have to make sure that we work to protect kind of all the users of the platform. So we've always had rate limits in place. But right now we're going to kind of look at our rate limits and make sure that we kind of split apart where they're enforced. Right now they're kind of enforced at the application layer. Some work that's already ongoing is to kind of break that apart and do it more at the infrastructure layer so that the applications can live their lives and be applications and not rate limiting infrastructure, which will obviously protect everybody against over usage for whatever reason, or over requests that come through. And then obviously as we make changes in that space, we'll be very transparent and communicate it out before we make those changes, just so that we don't surprise anybody. But I think that'll be a good positive step to helping overall reliabilities, to offset some, or to move some of that stuff away from the application layer.
Yeah, absolutely. I mean, then we're taking advantage of something that's tried, tested, and true versus trying to hand roll it ourselves and hope we get it right. Um,
Yeah,
so it'll be a good move in the right direction.
absolutely. All right, this one I know is at the top of a lot of folks' lists for, especially on the enterprise side. So um, everybody dislikes remembering different passwords and things like that. Um, and a particle this year, we rolled out our own internal SSO tool for all the applications and services that we use to keep everything running. And single sign-on is one of the, in my opinion, one of the most powerful security controls you can have, mainly because it doesn't really feel like a security control. It feels like a convenience feature for a lot of people. It obviously is used to get people around and to jump around into different applications and tools and things like that. It's long been on our security wish list. It's a little bit more complicated to implement a particle than, say, as like a traditional web service or something like that, just because of the intricacies about how we do authentication and access to devices and stuff. But I think we're getting to the point now where it's going to be fairly soon that we'll have some kind of SSO support, and the particle console icon will appear in places like Okta and Auth0, and One Login and Ping and places like that, all those kind of tools, to help get people into our product without having to type in a username and password, which will be extremely exciting and something that will be very valuable, I think, for a lot of our customers.
Yeah, absolutely. We always like it when our vendors support SSO.
Yeah,
So I know our customers will like it when we finally support SSO.
yeah, absolutely. Which is a good segue really into the security and reliability section. So yeah, security and reliability obviously have a lot of crossover at Particle. The security team and the ISRE team are two separate teams, but we are all on each of the stand-ups every day, and we work in very close partnerships. So that makes a lot of sense. And this is why this year we achieved SOC 2 Type 2 compliance. And I think that the SOC 2 Type 2, for those who aren't familiar with the standard, it's a formal security certification that looks at security controls that the organization has implemented across a prescribed period. For us, it was 8 months of look back. So we did our audit in September, and the look back period was January through August. And it obviously concentrates on technical security controls, but it also has pretty significant involvement from other areas of the business and just kind of governance and other things that go on to keeping the company running, and things like doing vendor assessments and managing which vendors we choose to use to deliver our service have all been kind of evaluated as part of the SOC 2. And I think, Debbie, it's definitely helped us kind of grow as a engineering organization and be a bit more rigorous about how we do certain things, right?
Absolutely. I was excited to see the SOC 2, when we endeavored to get that done, because it validated some of the things we were doing and encouraged us to improve in other areas. And it just makes for a nice story, when talking with customers, to have that seal of approval that says, yeah, actually, we do have some secure, we have solid processes.
Yeah, and the one thing I'll call out is on that slide is the best practice there at the bottom. You know, you should always build your technical security first and then go after the compliance after. A lot of folks do it the other way around, so they start off trying to jump around and adhere to some compliance standard and then build controls around that. It doesn't work, as we've seen many times. You should always do the right thing from a technical security perspective and then go get your certificates after the fact. Definitely. And yes, one of the core things that comes up a lot is the fact that availability is a security control too. It's a key component of any security program, is making sure that data is available to the people that should have access to it when they need it. And I'm sure you're all familiar with, if you've ever read any information security textbook or any general computer science textbook, the CIA triad there, not to be nothing to do with the intelligence service of the same name, just stands for confidentiality, integrity, and availability. The three key components of any data security program, and the things that we concentrate on every day. And with that, I think we should take some questions. I have not been looking at the questions as they come in, so I'll open them up now, if I can, and then we'll tackle some. All right. Does Particle, so this is a question, does Particle have any involvement in the Amazon LoRa Sidewalk project? If so, what? The answer to this one is fairly simple. No, we don't have any involvement in it. I know that's been a kind of a controversial topic that's come up in various places, but yeah, we're not partaking in that in any fashion. So that one's easy. I assume a blameless post-mortem has no institutional consequences, but how do you deal with individual pride and ego? That's a great question. Debbie, do you want to tackle that one?
Yeah. Well, I mean, you need to make sure you're not celebrating heroic events, and that I mean, I think a lot of it is you try to focus on team performance and not individual performance. Because ultimately, when you're dealing with a person's ego, they're not being a team player, and it's yeah, it's a tricky question. How do you deal with that? I mean, we try to approach everything as at the team performance, the team doing well, and not so much I mean, not that you don't celebrate when people have a win, because you also want to celebrate that. You want to encourage that. But I think when I say heroic efforts, it's more of I did this thing kind of in secret and I saved the day because I didn't really document things and it kind of broke it. But hey, look at me, I saved the day. Isn't that great? That's the kind of stuff you want to avoid.
Yeah, and I would say, I think that we kind of we avoid it just by kind of our hiring practices and how we get to where we are, right? Because I would say, and I've said this before internally, but Particle is a place where I haven't met the person yet that has the giant ego, which probably means it's me, right? Like, I'm probably the person and everybody thinks it, but yeah, I really honestly can't think of a single person that I think would fit that description at Particle. I'm not just saying that. That's something that I genuinely believe. So I think we do a good job in kind of hiring, and a people ups team helps us make sure that we we don't have that person in the team anyway. So yeah, it's kind of a bit of a soft answer, but I genuinely believe that.
Yeah.
The next question is, do you have some hard stats? What is your uptime ratio? What is your MTTR? How many significant loggable events have you had in the last year? Another good question. So in terms of like uptime and things like that, I think probably the best way to answer that is through a status page, status.particle.io. You can go there and you can see a lot of live data about things that have happened for MTTR and things like that. They tend to be negotiated into contracts with our enterprise customers. I don't think we published like a general MTTR. But yeah, you could look at the status page to kind of to see kind of real data from the past year. In terms of significant or loggable events that we've had in the last year, we definitely had a significant event in July.
It's July. Yep.
Yeah, and it was escalated from event to incident to pretty much like a DR situation very quickly. It was a failure at a database provider that we used, and it resulted in us kind of going full DR and having to do some significant failover work to make sure that we kept the service going. And I would say that Debbie was super instrumental in keeping everything going then, and it could have been a lot worse had we not had a lot of these things in place. So that's the one that really jumps to mind for this year as being the significant event, and a lot of good has come out of that following that event. We've made some changes. The postmortem is up on the blog from that particular event, and you can have a look at a lot of the changes that were made as a direct result of that. Let's see what else you got in there. All right. For someone not as familiar with Terraform, would you please say a few words about how Terraform interacts with Kubernetes? Do both allow for auto scaling? Do they share any responsibilities? Debbie, that one's for you.
So at Terraform, Terraform is responsible for creating the AWS infrastructure, and then Kubernetes is resting on top of that infra. We have a separate Kubernetes control plane that's interacting with nodes that we've defined in EC2. So they don't really compete with one another. It's more of the Terraform. We're using it as the bare, the basic building blocks to create the infra, and then we have Kubernetes running on top of that to run the applications and the microservices.
Makes sense. Thanks. There's one question I'm going to answer because it's about a security topic, which is how do you handle least privilege access for developers? So yeah, we run a DevOps model. So essentially, folks who are developing services are also responsible for kind of pushing them out to production and making sure they operate in prod. So in terms of least privilege, what we do is for any kind of hypersensitive function like an infrastructure change, there is a division. So I'll give you an example. So we take advantage of GitHub organizations to split application code from infrastructure code. And we give only a subset of people, the ISRE team, access to the repository in the infrastructure code organization to make those kind of changes and or make infrastructure level changes that could impact multiple services. And then we give developers only permission to alter the services that they're responsible for maintaining. And that's a nice balance because you can't have one developer in one team do something that would impact negatively an application or a service that another team is working on, and they would go through and work with the ISRE team to make any kind of underlying infrastructure changes as well. We also have kind of like full auditing and logging on admin tooling that allows, so say, for example, a developer is helping out a customer with a very specific problem. All that's audited and logged and stored independently in a separate system off the main infrastructure. It's in our SIM tool, so we can go back and kind of look in a place that we know only the security team has access to see kind of what somebody's been doing in the environment. So kind of splitting between the tooling and keeping detailed audit logs is kind of the summary answer there.
We should define ISRE. I saw in chat that someone was asking, what does ISRE stand for? Which is Infrastructure and Site Reliability Engineering. It's just the name that we use for the team that both Mike and I are on. Our team currently consists of SREs, infrastructure engineers, also QA, security. We do a lot of collaboration.
Absolutely. Are you running in AWS cloud, or do you have multiple clouds for reliability? We're running exclusively in AWS. The multi-cloud thing hasn't really come up for us just because of how we work. We are basically like a conduit, which customer information passes back through, and then we integrate with all the clouds and anywhere that will accept a webhook, essentially. So we haven't yet moved to any kind of multiple cloud option or multi-cloud deployment, just because we typically interface with customers, and we have customers in all of the major cloud providers. So that hasn't really been something that we've been challenged with yet. Maybe one day. I will say that we build in such a way that I think we're not tied to one cloud provider. I think we use enough tooling that might not be the easiest thing to do, but that we could break apart and use other cloud providers if we absolutely had to. Would you agree with that?
Oh, yeah. I mean, if we needed to, if that was a top priority, we'd be able to move over to a different, obviously it would be Kubernetes, and we'd either go to Azure or Google Cloud. We just, we've been with AWS all along, and that hasn't been there's been no pressing reason for us to prioritize that.
We should not forget the IBM cloud either.
Oh, yes, the IBM Cloud. Sorry.
Sorry, nerdy joke. Okay. Why was 100,000 online devices the number chosen as the test target? I believe that was because it was before we got to that milestone, right? And we wanted just to make sure that we were at the right.
Able to handle that. It was kind of like, wow, cool. We're getting close to 100,000. Can we handle 100,000?
Yeah, and then it's important to note as well that that target will constantly shift. We're already over 100,000 now. So as we, continue to grow as a company, we will continually shift that target to make sure that we stay on top of everything. Let's see. Is there a particle status page? Where, yeah, I kind of touched on this one, but status.particle.io. And I will say that we lean on the side of being more over communicative for our status page than not. So obviously one of the things with Particle is there are a lot of, there are a lot of moving parts, and we work with a lot of different cellular providers and things like that to make sure our devices stay connected. So we typically use, when you build on us, you're working with us to manage the relationships with all the cellular providers, so you don't have to. So we take the initiative to communicate out through our status page if we see like cellular issues in different countries and things like that. So you kind of can use our status page, if you like, as kind of a meta status page of all the different cellular providers and people that we work with, right?
Yeah, and it's worth calling out that that's something that we overhauled this year. We added in different graphing that is far more useful, which highlights if we're seeing some instability in the cloud. In fact, yesterday we had a minor outage where a telephony provider went down briefly, but a bunch of devices dropped offline as a result, because of course, if they're not able to communicate, they can't communicate to our cloud. Before we even got the status page up, you could see on the graph that it was yellow because we were seeing issues, and we got that status page up to say, hey, there's an issue. And then they came back online and all was good.
Yep. So a couple more and then we'll have to wrap up. Does Particle use automated testing for device OS testing? That's a question that I think would be better answered by some of the embedded folks, but yes, is the short answer. There are a series of kind of build and CI tools that we use for running a series of tests when we build those out, for sure. And then the next one is, I just saw it. Okay, so we're evaluating Particle for our Edge IoT or our IoT Edge products. Our customers peg the cost of downtime at between 250,000 USD and 500,000 USD per minute. How do we get reliability numbers, especially uptime from Particle, so we can perform a better evaluation? What I would answer that with is actually a nice one to kind of lead on to the last slide is work with our sales folks. If you're not already in touch with them, you can, work with an account executive who will be able to discuss those kind of figures, and also, write you a contract with with the specific terms and conditions that you need in there. We work with some, like I've said during the webinar, um, a, a really wide variety of customers in mission critical environments, and so it's that kind of conversation will not come as a surprise to our sales team. So go ahead and have that conversation, and I think that everything will come together there. But yeah, now I'm really curious as to what that downtime cost is tied to, because that's pretty significant. I think we got time for one more, and then we'll wrap up, which is, which tools do you use for your deployment pipelines? And I picked this one because it's a good question, because the answer is all of them. Debbie?
Yeah. So which tool? It's for the deployment pipeline. Yeah, it is kind of a God. It's an area I want to standardize more on, to be honest, because we've got Travis in there, we've got CodeFresh in there. Probably something we could have highlighted as areas we're also wanting to improve is standardizing on that. We've got a tool that we're using to. Helm is what we're using to actually get containers out into the Kubernetes stuff. But we've got a couple different pipelines as far as doing the automated testing. Before we push things out to prod. And then we've also got, we've got a homegrown chat ops tool that's ultimately using Helm to get the containers scheduled and pushed out to prod.
Yeah, there's a lot of tooling there, and yeah, we may have needed to add kind of standardization onto the things we can improve upon in 2021. All right, well, we're going to wrap up. So thank you all so much for coming. I know there were some questions that we didn't get to. If you have any kind of further questions that we missed, please ping sales@prodigal.io and they will route the questions accordingly. We're all very, very close, so the questions come in and they always get to the right person. So don't worry about that. Just wanted to thank Debbie for taking the time away from Terraform and Kubernetes and all those good things for coming out and celebrating some of the work that's been done this year. Like we said, kind of the reliability and operational work is not something that's often celebrated, but it should be. Kind of the behind the scenes stuff absolutely deserves to be, and it's been a big push for us this year. So thanks for coming, and thanks for joining, Debbie.
Thank you, Mike. It was fun to nice to highlight the work we've been doing. And yeah.
All right, well, have a great holiday, everybody, and we'll see you in the new year. Thanks very much.